Alright, so today we're talking about differential equations. We've actually been working with differential equations this whole chapter, but a differential equation is an equation that involves derivatives or differentials of an unknown function. So if we're given the derivative, we need to figure out the original function. That's a differential equation. To solve a differential equation, we need to find the function or functions that have the given derivative. So up until now, we've been finding all the possibilities. We've had plus c in all of our final answers because there's lots of different answers to those questions. But if we're given a little bit of information, we can actually figure out an exact answer, an exact equation. So you'll see in these examples, like number one, for number one, we're given this point right here. It tells us in the original graph there's a point at 0, 2. So that little bit of information about the original graph allows us to figure out exactly where that equation is, or what that equation is, instead of writing all the possibilities with that plus c. So let's go ahead and take a look at number one. I'm going to start off, I'm going to rewrite this. Instead of derivative f of x, I'm going to write it as dy dx. Kind of tie it back to something we talked about earlier in the chapter and what we're going to see a little bit later in the notes. So dy dx equals 6x squared plus x minus 5. What I'm going to do here is multiply both sides by dx. Because when I'm solving a differential equation, and more importantly later in some problems that we'll see, I want to go ahead and get all the y's and dy on one side. So we don't really have any y's, we just have the dy over here. And then all of the x's and the dx on the other side. I want those variables separated. Once they're separated, then we can do the antiderivative of both sides. So on the left, we're just doing the antiderivative of 1 dy. So what is that? Y, right? And remember, we talked about how we don't have to do the plus c on this side because we're just going to move it over to the other side anyway and just end up with a constant on the right side. So we just need a plus c on the right side for this type of problem. All right, we can do the antiderivative here. We're going to end up with 2x cubed plus 1/2 x squared minus 5x plus c. Right, so normally, or what we've been doing the past couple days, that would be it. We'd be done. That's our answer. But with this extra little bit of information here, we can figure out what c is in this case. Right? We can figure out what equation goes through that point. So we're just putting in 2 for y, and it's really nice when they put 0 in there for x because a bunch of stuff cancels out. Right? All of this cancels out, and we're just left with c equals 2. So our final equation here, y equals, or we could write f of x equals 2x cubed plus 1/2 x squared minus 5x plus 2. We can put that value back in for c.